I called myself a Sooner rather than a Boomer.
Well, I guess it's almost time to go.
Sure, might as well.
So, well, it's good to see and hear you people again. We have a lot to discuss. The top news that we'll be talking about is how that U.S. government hack happened and what it means. I know a lot of people have been wondering what is going on. Is there going to be a lot more of it? Anyway, that's the top news. On coronavirus, the UK apparently is spooking everyone. I know I've heard a lot of people talk about it with this new COVID-19 strain. Now, here's what scientists know about it. In technology, and I don't know, do you want to have a keyboard without a keyboard? Apparently, a new device can detect which hand gesture you want to make for a keyboard. And something I don't really understand what it's all about. A magic angle graphene and the creation of unexpected quantum states. What's this all about? On space, as you may have been aware, Japan has a space agency. They wanted to go up to an asteroid, collect samples, and bring them back to Japan for analysis. And they succeeded. In environment, Tesco in the UK removed 20 million items of plastic from Christmas ranges in the UK then. But can we do it? Apparently Amazon could if they cared enough. In biology, we're going to hear a lot about the incredible variable bacteria living inside your mouth. Oh, I don't know what I want to know about that. And in health and medical, Richard says, when can I ask my doctor, how about growing me a new kidney? Because apparently growing human organs seems to be on the drawing board. That sounds fascinating. So that's all that we'll talk about today. And now, Richard, let's start off with how did the US government hack happen and what might it mean?
This is to say this was a problem is kind of extreme understatement. The Russians were able only to hack in the US government, only the Defense Department, the Commerce Department, the Treasury Department, the State Department, Homeland Security, and the part of the Energy Department that oversees America's nuclear arsenal. And this hack apparently started in March, and we were not able to find out about it until very recently. And the article we have is based on an interview with Jason Heatley, who's a computer security expert and was an Air Force officer and a White House official in computer security. So he's fairly knowledgeable. And he says, to put it in war-fighting terms, Putin has us entirely at risk of attack, and we had zero idea. And the thing is that this hack has not only been in the American government, one of the other places they hacked was Microsoft. Opening up the possibility that maybe they figured out how to insert code in Microsoft releases and affect almost every computer in the world, except those Apple guys. And they, so far, it looks like they were only in non-secured system, so they could get organizational structure and non-classified plans and things like this. They weren't able to get the keys to the kingdom, the nuclear secrets, and Trump's personal phone number. They have to ask Putin for that, I guess. And, they did it in a tricky way that they didn't attack the people directly. They found some obscure company that nobody ever heard of until a few days ago. The Solar Winds is the name of the company, and they make some piece of critical software for the network infrastructure. And so it's kind of the plumbing that everybody uses to run their network on. And so far, it looks like that they are just doing espionage, but things are not always stable in the world. And what happens if instead of doing espionage, since they have access to all these systems, then they start doing disruption, which could happen. And then another issue is, so far, we only really have heard about this in the US. The systems that SolarWind supports are all over the world. And so we haven't heard it from Europe, UK, Japan, or any of those places yet. But you can bet that these guys are in there. So that's our favorite Christmas story this year.
Comments?
Yes, I think recently, was it yesterday or the day before, Biden made a public speech to the nation saying his team was not getting the cooperation from the Defense Department and other departments for the transition. On top of that, Trump said, well, it could be the Chinese. So I just wonder what's under the carpet there, what Biden is going to find as far as the security of the United States. I don't know if you heard that speech by Biden.
I heard of it. I didn't listen to it. But so it wasn't the Chinese. One of the things they're able to do is analyze patterns of attack, and they have, they think, positively identified the attacker as a known group of Russian hackers that have done other things before. So they have kind of their MO, and it fits their MO exactly.
Yeah, this is Vijay here, and I listened to a 2-hour webinar at the McCreary Homeland Security Institute in Charleston, which is, I think you relate to the university, and they're pretty well-known Homeland Security type of nonprofit policy institute. And they were positive it was the Russians, and they feel it was espionage. They are basically trying to steal as much information as possible, including the vaccines and stuff like that. They want to get into, they want to know how the vaccines are made, etc. So it was an espionage effort, and it positively identified it as Russian. what is worrisome is Trump has not mentioned Russia at all ever since this happened.
Well, Trump.
So his comment would be China.
I'm sorry, go ahead.
No, that's it. Go
Okay.
ahead.
And so this just demonstrates the amazing vulnerability in our digital societies. We, are, it turns out, critically dependent on some small piece of software that nobody ever heard of before this happens. And all of a sudden, we have an international vulnerability that is being attacked. And again, right now, they're just doing espionage, but the espionage is not the only kind of bad deeds that happen. Sometimes if things are bad and trouble is collapsing, then people just blow things up. And so that's the kind of potential we have.
What do you think? So Richard, what do you think we could do to protect ourselves?
I think we have to do some fundamental changes in the architecture, and what we're going to have to do is going to end up making, right now we're used to an internet that is free and open and available to everyone and easy to navigate around and get stuff. And to protect ourselves, it means that we're going to have to make it less free. And there are things that they can do. There are the people who started the internet to begin with are talking about a new version of the internet where in all of these kind of things are better dealt with. But, the architecture we have around the world that is designed to share information is vulnerable to attacks. Most of it's controlled by things like passwords, and passwords are notoriously insecure.
Yeah.
Anyone else? If not, we'll go on to our coronavirus story. Probably you've heard about this new COVID-19 strain, and it seems that it's spooking everyone with it. And here's what scientists know about this new UK COVID-19 strain.
And this particular summary is from one of the places that I trust as an information source. It's MIT Technology Review. And if you're not familiar with it, it's a real worthwhile organization. And they detected this apparently in September in the UK. They detected it in the UK because in the UK there is one of the most active programs to identify and screen viruses and sequence viruses. It's active enough where there are 275,000 coronavirus genetic sequences now in the world database, and 45% of them have come from the UK. So that's how active they are. And it looks like that the early results say that it's 70% more transmissible, and they discovered it doing analysis to some place where it looked like there was a new virus happening, and the infection rates quadrupled in a short period of time. Because of it now, most countries have banned travel to the UK. And if this really is a strain that is that much more transmissible, then it won't be long before it's the dominant strain on the planet. It looks like death rates have not increased, but if it's the same percentage and you have more people getting sick, you're going to have more people die. It also, they strongly believe that the viruses that the vaccines rather we have now will work, and the vaccination programs are going on around the world based on that assumption. This is still an assumption. We don't know yet. What we do know is that our capability of making vaccines is a lot better than it used to be. And so if it is some new variant and it takes a new vaccine, then it won't be long before we have one. So that's what we know now. And it's just another story about things might get bad as if they're not bad already, and get your vaccine shot.
Any comments?
Yeah, I just read in today's Washington Post this morning that they have found this particular virus signature in 60 countries now.
Yes. Yes.
Really?
So they're not sure it originated in England or that it's only restricted to England. It could have come from somewhere else to England or to the UK or vice versa. Right. But they found it in 60 countries, which is a little worrisome.
And they found it in England because they have the best vaccine virus survey. Now, they think that it's very likely that this mutated virus came from some patient that was immunocompromised and had given a bunch of different treatments to make him well, and the virus lived through it and mutated because of the treatments the patient was getting. So we may have brought this virus on ourselves by our good care.
Other comments?
Well,
go ahead.
It's Andrew Clarke. I'm VJ's friend.
Yes.
Hello. The reality is these things are mutating all the time and evolving all the time.
Yes.
And evolving and at quite a bit faster than the rest of us are evolving. So it's inevitable that there's going to be changes, and we'll just have to adapt to them.
The last I knew that they didn't know if the current vaccine would be effective against it. Have they figured that out?
Again, they don't have any proof. They believe it will be effective.
Last night I was listening to an interview of Dr. Fauci, and he said that the attachment mechanism of this new mutant to the human tissues, to the lungs or wherever it attaches to and grows on, is very similar or identical to the existing viruses. It's got those tentacles. What do they call them? Those hook-like things that grab on to the human tissue. That's not any different. And so the vaccine attacks that attachment mechanism. So it should work. The current vaccine should work with this particular mutation, they think, but it's still a guesswork.
But, and again, overall with these SARS vaccines, they know more about it than just this one. And they know, as Andrew was saying, they're able to see a couple of significant mutations every month. So these things, that's a lot.
So if we move on to go ahead, Johannes.
No, I was just going to say, they say that your chance of being infected is proportional to the time you spend with somebody who's already infected. So if this is more, if the new strain is worse, perhaps you spend less time with somebody infected and you get infected. I don't know. What are the parameters?
I wonder, yeah. Okay, then moving along to technology. Apparently, you will soon be able to have a keyboard without a keyboard, using your hand to make different kind of gestures, because a new device will detect those hand gestures and make a keyboard. Richard, what's that about?
Now, they are always looking for new ways to either do input or output to computers. And one of the things that they have been looking at particularly are different forms of motion sensing, because they have the idea, if you can sense the motion, then that gives you a way to control things directly without such crude things as keyboards. And so here, what they have done is they've made a cuff that you put on your wrist. And the cuff on your wrist then senses the electrical activity of the neurons that go down your wrist into your hands and move the muscles. So before the muscles move, there is this signal. And they have a system now that incorporates this biosensor and the adaptive AI that is used. And right now they can only do simpler things. There are about 24 hand gestures that they can detect. They can tell if you give a thumbs up or a thumbs down, for example. That's all pretty gross. The AI that's running these is getting better all the time. And this particular AI has a different architecture than most, and that is it's not only doing the sensing locally, but it's also the AI is also local. So it's not like Google, where it takes it and sends it back to the big server, and the big server munches it, and then it goes back to you and goes in there. It's all local, and it continues to learn. And what they believe is this Rift Cup that they have developed, that they will get it good enough so it will be able to detect your hand motion and be able to detect it well enough to, for example, be the computer keyboard, or to be able to drive your car without a steering wheel. I'm not sure. I would rather try the keyboard thing first than the car, but that's just me.
Any other comments?
Well, it looks to me that it's a very complicated thing, because when it comes to a keyboard, there are, I don't know how many keys there are, but looking at it, I'd say at least 50 plus keys. And so if you are working a keyboard, where some people can type literally blindly, that's one thing. But if you have people like me, I have to look and see where I'm going. And then with 2 fingers, check out the various letters and symbols. So I don't know, unless they can translate thoughts that you have in your mind and put that into a computerized environment. I don't see where this is going to be very useful.
But maybe it's, they talk about it as a learning system, and for it to work effectively, it's going to have to be able to learn how you do it. And so they're going to know when you search around like this and then poke, then you're hitting an E.
Yeah, right, right.
So Richard, how does this work? You pretend you're typing on a keyboard? Is that what it does?
This works. It has a cuff on your wrist, and in the
Yeah.
cuff there are sensors, and the sensors detect the nerve signals that are going down through the nerves into your hand. And the AI that's attached to it is able to learn to interpret those nerve signals as hand motions and be able then to decode the signals into what the hand is going to do.
You mean like based on an old-fashioned keyboard? I mean, otherwise, how do they pick up any signals about what you mean?
All of the movements on the keyboard are done by your muscles, and the muscles are controlled by the nervous system, and so they're able to know it well enough to figure a lot of that out. They still have more work to do, but it shows the kind of direction that they're trying to go. I've heard of different people doing different motion sensing things, again, trying to do like these guys say will be able to do, which is, have the keyboard without a keyboard is a classic problem they're trying to be able to solve. That certainly would help if we had one of these on our smartphone. I think all of us would like it.
So you pretend you're typing on a keyboard.
That's right.
Is that it? Oh,
yes.
Okay.
And I don't know, I think John brought out something that is a good point. What if you're a terrible typist and a hunt and peck typist, and what do you do then? I don't know. I think, again, they just need real good AI.
Maybe.
I think it would be more useful in controlling a moving vehicle. You mentioned trucks or boats or airplanes even, because there is some time lag between you thinking about something and doing something. And so you can literally reduce that to virtually zero. But, but there's just a limited number of things that you do.
Now, also, they're saying where the use is probably going to show up first is with prosthetics. For example, this would be great for a guy who lost his hand and has a prosthetic hand. And so that's where you'll see it first, is in the medical appliance business.
Well, yeah, I can see walking motions, that sort of thing.
Well, I could see if you had a projected keyboard on a surface. No, really. You project the keyboard, and then the system tells you, well, type this letter, type that letter. So you have the coordinates. And then from there, you can pick up where you want to type.
Well, with this kind of thinking, we maybe can get you on a design team, a research team.
Okay, I'm ready.
Okay. If any employers are watching today, Johannes, I have his email address.
Any other comments? If not, we'll move on to materials. For a long time, we've been talking about graphene and two-dimensional stuff. Now, what's this that we're going to talk about today about magic angle graphene and the creation of unexpected quantum states? Richard, tell us about it.
Now, the only thing that gets in my way explaining this stuff to you guys is the fact that I know so little about it. Excuse me, my wife is after my wallet, I think. Do you know the gesture reaching for your wallet? Okay. Anyway, my wife came into the room, and it was not to be affectionate. It's to be able to pay the house cleaner. Okay. Anyway, magic angle graphene is something that we've heard about now for the last couple of years. About 10 years ago, they started to discover that something was funny with this graphene and the two-dimensional material. And then a couple of years ago, they were able to demonstrate what they call magic angle superconductivity, where they take two sheets of graphene and put them 1.1 degree angle between the two of them. And as long as you have that angle and are at the minus a zillion degrees, then they become superconductors, which nobody expected. So what these guys have done is then go and try to study that and figure out what is happening to be able to do that, which is a good question. And so what they have found, one of the things about graphene is each sheet is got this very orderly layout of these hexagons of carbon. And because the atoms are in an orderly layout, then the electrons are in an orderly layout. And all of this stuff turns out to have to do with interactions between electrons, which, and then they say they have detected unusual quantum states when you do it. One of these is superconductivity. Another is magnetism. And, you know, carbon is not a magnetic material, but if they do it right with the right layers, with the right twist, then suddenly it is magnetic. And so what they found when they studied the actual array of electrons is that under the right conditions, the electrons want to form this orderly structure. And within this orderly structure, it's funny because they talk about it as being an insulator state. You know, carbon is the carbon graphene is a great conductor of electricity, but they can make it not a conductor, an insulator. And what they say that makes the superconductor, it's kind of strange. I don't really understand it, but they say in this insulating structure they make, the electrons in the middle of the area are insulators then and will not conduct electricity, but the electrons on the periphery then become superconductors and are able to conduct the electricity perfectly, even in structures that are not perfect, like things are often in the world. And anyway, so they are discovering that if you get the right patterns of electrons interacting with other electrons, unexpected things happen. And they're starting to be able to catalog that. As I say, two of the unexpected things that I'm aware of are becoming superconductors and developing magnetism. And I'm not sure what else is in that bag, but I think there is a lot there. And this does not behave in the way that we understand.
I wonder how they were able to manufacture something 1 atom thick.
I wonder how they manipulate those hexagons.
I'm sorry, I heard two comments at once and didn't understand either.
Well, okay, I'll go first then. I just wonder how these hexagons connect with each other. How they manipulate that? How they turn one against the other?
The electrons form, again, they say if you have electrons in just the right pattern, then the electrons start interacting with each other in ways that we didn't know about. And it's these electrons interacting with each other that are causing all of this stuff, they think.
Well, how is it that they're able to manufacture a sheet one atom thick?
Oh, the way they do it is it's so primitive that it blows my mind. They have a pile of carbon and then they put sticky stuff on the top and pull things out of the pile until there's only one atom left. And I'm sure that's an oversimplification, but I think it's not much of an oversimplification.
Any other thoughts? If not, let's go on to space. For a while, we've been talking about other people like China getting involved in space. But here, this is about Japan. And their goal wasn't to go to Mars, it was to go to an asteroid, collect samples and bring them back for analysis. And apparently they were very successful. Richard, tell us about it.
Now, the first thing is that the mission worked. The second thing is that they brought back more than they expected, which means if you're going to do science on this stuff, you can do more science since they have more stuff. And then among the stuff they found, this is one thing I don't understand. They found gas. And I thought, this is an asteroid out in space, no atmosphere and stuff like that. What's gas doing on the surface of an asteroid? You'll have to tell me. Another thing they found is they expected to come back with dust. And so then they were going to have to examine almost each particle of dust and figure out what it's made from and all that stuff. And it's a little more of a problem when you're dealing with dust. But they also came back with pebbles. And the stuff I read, I can't imagine, but the scientists were so excited. We have pebbles! And that means, pebbles, I think the deal is that pebbles are a lot easier to analyze than dust. And then among the dust, and part of what is exciting is that there is all this organic dust. And this is from 4 billion years ago in the early days of this solar system. And one of the questions we have is, how did life arise? And there are lots of different ideas about it. And some of those ideas have to do with this organic dust that is just in the universe. And now for the first time, they have some. And so they don't know what it is yet, but the chemists are madly trying to analyze it and take it apart and see what they have. And so they're excited. It succeeded. It exceeded beyond their expectations. They're going to be able to do science and more science than they expected that they were able to do. And by the way, this particular Japanese mission is not finished yet. The satellite now has started on an 11-year voyage to another asteroid rather, and they're trying to study defenses against asteroids that could fly towards the Earth. Now, I believe what they're going to do is, because they don't know really the energies that are involved with the asteroid and masses and all of this stuff, is they're going to do a well-calibrated experiment, which I believe is aim the spaceship right at the asteroid and try to hit it, and then see how much it moves out of the way, and then they'll be able to make some estimates about mass and energy and things like this after that test. That sounds like something that teenage boys would think about. What happens if I do this and hit that? They're going to find out.
So did they use manned spacecraft to get the samples of the asteroid, or is it unmanned?
It's unmanned. It's unmanned. It's absolutely unmanned because we don't have the technology to send people up to do that yet. People are a lot heavier than little robots, and so you need a bigger rocket.
And wasn't this asteroid a lot further than the moon? It was quite a distance away. Right?
Yes.
Yeah.
And again, this is, in my mind, this is connected with what the Chinese are trying to do on the moon. They're both, the motivation for a lot of the work is basically mining, in the one case on the moon and on the other case in the asteroids. And it excites me actually to see them doing experiments that are about how do we start to mine the asteroids. There's a lot of stuff out there.
Any thoughts? Then let's move on to the environment. Apparently, Tesco in the UK removed 20 million items of plastic. And could we do that? What's that all about?
This was exciting to me, especially in this Christmas season, where one of the things that you see from Christmas is the garbage cans full of wrapping material and plastic that is used to contain all of the merchandise that people bought. And anyway, Tesco apparently is serious about this effort, and they are the UK's largest supermarket. And one of the things they did, it sounds like a small thing, but they did their own private labeled crackers, and these were wrapped in plastic. And now for the first time, they're not wrapped in plastic. This ended up saving 14 million pieces of plastic that would have gone into the trash stream. They also, another thing they did that was significant, though maybe it's not we're aware of, is they removed glitter from all of their single-use products and packaging, which meant that wrapping paper, gift bags, and all of that stuff are now completely recyclable. The glitter apparently is a real problem when you're trying to do recycling. And it turns out that in the UK, it looks like they have a regulatory crackdown that is happening on plastics, and it comes into effect in 2022. And there will be a new tax on plastic packaging that fails to meet the standard of at least 30% recycled content. And this has companies in UK, and now it's spreading to Europe on a mad campaign to reduce the amount of plastic they use in their products and packaging. And I would say, for me, this is long overdue. And the one thing I would say about Amazon's packaging, I buy a lot of stuff from Amazon because of the pandemic and because they have things that they don't have at the local stores in Mexico. A lot of the stuff from Amazon is in boxes and things that are recyclable, but still there is so much plastic that is used in this packaging and stuff. And for me, when I see it, there's a part of me that it just makes me deeply troubled.
Any other comments?
One thing that I saw or listened to on the BBC, they were talking about using reusable shopping bags instead of plastic bags for your groceries. Yes. And the fellow said that the energy involved in preparing the reusable bags would require you to use it 140 times to equal the amount of energy that is used in preparing the plastic bags. And so he thought that we needed to do more about the life cycle energy costs of these things. And a lot of knee-jerk decisions are made to reduce the kind of visible impact of this stuff without looking at the overall life cycle impact of it.
I think that's a very good point.
Any other comments? Okay, then, moving on to biology. What's this about all this bacteria in our mouths?
Well, there is a part of this story that makes me uncomfortable anyway. And, it's not just a bacterial community in our mouth. They say literally in our mouth, there are trillions, count them, trillions of bacteria. So those are tiny little guys, I guess. And one of the things that the interest here is that if you can really understand what is happening with these bacterial communities, these are the things that make up the microbiome. And we're moving towards a medicine in which being able to change to treat the microbiome will be a beneficial thing in health. And so they feel like, to start with, that the mouth is a great place to study it, because it's available. And so they can get to it. One of the things that they found that surprised them so far was that the bacterial community in my mouth there are actually several different communities. One is the tongue, and the relationship between the bacteria on my tongue, Fred, they say are closer to the bacteria on your tongue than they are to the bacteria in my cheek.
Wow.
So there are these distinct communities of bacteria, and three of the places that they see these are on the tongue, on the cheek, and on the teeth. And so, again, they are using now, the reason they can study this is because of the latest revolutions in the genetic sequencing. Then they're able to do the kind of analysis they need to do to identify the community in your mouth. And they have taken samples now from hundreds of people and looked at these thousands and thousands of different kinds of bacteria, and now they're trying to make sense of it in terms of individual communities and what you can do to make individual communities thrive and stuff like this, so that they can then start to figure out on a better scientific basis things like probiotics, things that are intended to treat your microbiome. And it turns out all of these bacteria in the community in our mouth with its trillions of bacteria are a convenient place to do this study.
Any thoughts?
I've been reading up a little bit about the microbiome, and it's fascinating. They're saying that there's bacteria and viruses in every part of our body and on top of our body, on our surface as well.
Yes, and the viruses outnumber the bacteria.
Yeah, and the total weight of these damn things is almost half our body weight.
Wow.
Yeah.
Wow.
And not only that, the microbiome of each human being is so unique. Yes. That you can actually, it's as unique as your fingerprint or your retina scan.
Yes.
So it's a pretty mind-boggling thing. We are really all very part of a very complex ecosystem. We are not unique individuals. We are unique individuals, but we are part of a much bigger microbiome. That's a mind-boggling
yes.
concept.
Yes, yeah. Yes.
And in fact, some scientists, I don't know, one of the US universities, they had this perfectly sterilized test booth, and they were putting in human beings and blowing air through it, and whatever microbiome they could get out of it through the ventilation system, they were analyzing the genome, and every human being was unique, and they said it was almost like a fingerprint.
Yes.
Yeah.
Other comments?
And again, the research that they're able to do now is only because of the gene sequencing skills that they presently have, because to be able to figure out what are the individual components of the 1,000 different species of bacteria they find in a sample, then it takes wonderful genetic tools to be able to analyze it.
And it's become very economical. At one time, it cost millions to
yes.
sequence. Today, it's only in the tens of dollars.
Yes.
Wow. Yeah. Okay, then moving on to our last story. Richard says he wants a new kidney. Now, what is this about growing human organs seem likely to be quite possible? What's that?
Well, they have discovered a different use for stem cells. And I know stem cells are a big subject nowadays, and what they have found is that injecting a particular kind of stem cell into pig embryos cause that pig to, as it grows, grow the organ that those stem cells were from. So if you wanted a new liver, which is what they're working on first, then you inject the infant or the pig embryo with human liver stem cells, and when the pig grows up, it has a liver for you. And they particularly are excited about this technique of using human stem cells grown in the pigs to grow new organs, because since they are human organs, they believe that the rejection problem will be a lot less than it would be if they're trying to give me a pig kidney. The odds are I'm going to reject the pig kidney, and they're less that I'll reject the human kidney. And there are thousands and thousands of people around the world who are on various organ transplant lists, and in pretty much every case, the supply is a lot less than the demand. So many people die while on the list. Maybe this is a way where you won't die. I guess this is a way to save all of the non-Muslim, non-Jew people who need organ transplants. I guess, would you have trouble with the ethics of a organ grown in a pig if you could not eat pig meat? I don't know. Moral questions.
How did they overcome the non-reaction by putting a human stem cell in a pig embryo?
I don't know. I don't know, but they're able to do it, and it looks like it's a very successful process.
It's interesting, but that article talked about, I think it was in Maryland, they were doing it at Baltimore, but there was quite a commercialization draw on the article. They were looking for investors and business interest in it that would help fund the original research they were doing. Which is reasonable.
That's one of the reasons why you publicize this kind of work, is to get money to support the effort, because it's not cheap.
Yep. Other thoughts?
Well, I just had one comment about the pig and the Jews and Muslims. The Chinese vaccine for coronavirus.
Okay.
That is made using the lipid they use for that vaccine is from pigs, because China is the biggest market for pork. And so all the leftover lipids from those pigs' carcasses, they use it for the vaccines.
Okay, that's recycling.
Yeah, and they sold it to a lot of Muslim and countries, as well as some pieces to Israel. And so there were the Jews and the rabbis and the mullahs were really struggling with the ethics of it, and the Muslims are still struggling with it. The Jews were very clever. You know, the rabbis opined that since it's injected in your body and it doesn't touch your digestive system, you're cool, because it has to go through your digestive system. That's what's prohibited.
Okay. That sounds like...
I thought it was a very clever ethical argument to approve the use of the Chinese vaccine.
Yes.
Okay, then Richard, thanks so much. And thanks to everybody for participating. And we'll see you all in a week's time.